All right, this is problem 10.1.61, and the problem is Pamela's computer printer allows for optional settings with a panel of 5 on-off switches in a row, and we want to know how many different settings can she select if no 2 adjacent switches can be on. Okay, so the restriction in this problem, and whenever we're doing any kind of counting, we always want to look for the restriction, because the restriction is going to be the thing that we're going to have to focus on in order to be able to answer the question. So the restriction here is no 2 adjacent switches can both be on. Okay, so the easiest way to answer this problem would actually be to use a tree diagram to list out, to organize our thinking and list out all of the possible options of how this could happen. Okay, so what I'm going to do is draw out a tree diagram for us, and I'm going to do it sideways here on a piece of paper. And we're just going to follow this scenario through each of the switches. Okay, so if we start with the first switch, the options for this first switch are it could be either off or it could be on. Okay, so that's, you know, what could happen with that first switch, and then we're going to go from there. So if the switch is off, then in the second switch could either be off or on. And the reason for that is that that's okay with the restriction here, that it's just saying we can't have 2 adjacent switches both being on. So if it's off, the second switch could either be off or on. But if it's on, then the second switch can only be off, because if it's on, then our stipulation here is not met. Okay, and we're going to follow this same reasoning all the way out to the 5th switch here. So for the third switch, if the second switch is off, then the third switch can again be either off or on. If the second switch is on, then the third switch would have to be off. Okay, and what we're doing here is we're counting all the possibilities basically just by listing, systematic listing, but we're actually using a tree diagram to do the listing. And then in this problem right here, or this piece of the tree diagram, if we're off right here, then the third switch can either go off or on. Okay, and if we keep following this reasoning, the fourth switch, from an off, we can be either off or on next to it. For an on, we can only be off. For off, we can be off or on. And again, off or on. And an on can only be next to an off. Okay, and the fifth switch here, the off can go to an off or on. The on only goes to an off. The off can go off or on. And we're just going to follow this all the way down. The nice thing about tree diagrams is it makes it much easier to count something that would be difficult to count without a tree diagram, because we need to be able to see the different scenarios as we move through the switches. Okay, and remember up here, I've listed these as my switches. So this is switch 1, 2, 3, 4, and 5. Okay, so if we look at this and just count it, it looks to me like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So there's actually 13 different settings here if we can't have any 2 switches being on. Okay, so that would be 13 in that problem, and that's it for that problem.